Hello and welcome to the webinar number 37 in the ZebraBI webinar series. My name is Andre and today I'll show you how to make your Power BI reports and dashboards run much faster, up to 10 times faster, hopefully in some cases even more. Why is this important? We have all seen slow Power BI reports when you open the page and then you just loads and loads the visuals. It may take 5 seconds, 10 seconds, 20 seconds, or even more. We've seen reports load a minute or even more, which of course renders them completely useless and to the point where you will actually not put them into production. So performance optimization is a massively important topic, and it's also a complex topic. So I'll try to keep it very practical today, and I will show you how to tackle performance optimization in 3 steps. Number 1, to start with, how to analyze your performance, how to check where your performance bottlenecks actually lie. In the next step, we'll try to speed up the data model, which is where most of performance issues in practice actually lie. And then in the 3rd step, we'll take a look at the front end, the reports, the dashboards, the visuals, and how to speed up the actual reports themselves. All right, so we'll share a lot of useful resources and download links, and we'll have a Q&A in the end. We are also recording this session, so you'll get the recording afterwards. And if you're watching the YouTube video, head over to the page in the description below to get all the materials. All right, so I'm Andre Lapine, the founder and CEO at ZebraBI. I'm the Microsoft Most Valuable Professional and the IBCS certified consultant. And with me, I've got Mark, who is the BI consultant here at ZebraBI and will help me with your questions. Mark, would you please say hi to the audience?
Hello, everyone. You know the drill. I'll be monitoring the questions you keep posting in the comment section, and during the session we'll try to answer as much as possible, but we'll also cover them in the follow-up and later at the end in the Q&A dedicated time slot. So Andre, back to you.
Thanks, Mark. All right, so keep those questions running and we'll answer them in the end. Now let's dive into the topic. So first of all, how to analyze your performance. And we'll start by looking at the performance analyzer, which is a built-in function inside the Power BI desktop, which should be the very first starting point when exploring your performance issues. All right, so let's take a look at a report page. And first of all, how do you analyze the performance of this page? So we'll head up to the View tab in Power BI, and you'll find the Performance Analyzer here. So I'll just click here. And now you've got this very handy tool built into Power BI Desktop, and we'll just hit Start Recording. All right, now Power BI is recording my performance. You can clear the display here, and we'll refresh the visuals. Okay, so now Power BI is loading all of my visuals. Still loading some data here, and now it looks like it's done. And you've got a result here. Okay, first of all, from this result, we can see that a lot is going on this very page in Power BI. So there are lots of visuals here, including images, some lines, some cards, charts, tables, other elements here. There are actually lots of elements, including the slicers and so on. And of course, each of those elements on the page adds to the time needed to query the data, load the visual, display the visual, and so on. So all this information is here. And first of all, the important thing here are the timings, of course. So this is the duration in milliseconds. And looking at those timings, you'll find that the actual maximum number here indicates how long did it take for the whole report to load. All right, so let's open this one. This was the last element here, the matrix. All right, when you open this, you'll see this time broken down by a couple of items here. So first of all, the DAX query. The DAX query, which took 130 milliseconds. That's quite fast, so not an issue, not really an issue here. However, the visual display here took 500 milliseconds. That's already a half a second to render this matrix. This is a native PowerBI matrix here. And then there's this category called Other, which actually means how much did this matrix visual, actually wait for the other visuals to load. All right, so each of the visuals has those three categories here. And the other means that this is basically the waiting time for the visual. All right, so in my case now here, we can see that the DAX query, so the data part, is quite fast. This is because I'm using the import mode here in this case. And the visuals display, in some cases, it can be quite significant. So half a second can be worrying, especially if you have a couple of visuals on the page. And if you have the situation where the other category is very big, which is exactly my situation here now, this means that you simply have too many visuals, right? So this page needs to be redesigned, and the number of visuals on a page needs to be decreased significantly. All right, so let's take a look at another example. This is another type of landing page. So let's refresh this one. All right, load it much faster. We can immediately see that there are much less elements here. So we've got 4 visuals, basically. These are the custom visuals, our custom visuals. So the ZebraBI charts, cards, tables, and another tables visual. It doesn't really matter if you're using custom visuals or native visuals, but this page loads much faster. Mostly because there are a lot less visuals on the page. So basically we have 4 visuals with the content. Then we have 4 visuals here representing the slicers. Then we have a couple of other elements like, the text box here, and there's this button, and and basically and there's a drill through button here. It's actually a hidden button. So basically 4 slicers, 4 content visuals, and 3 additional elements, which is manageable, and this is why the page has loaded much faster. Now, the number of visuals does not necessarily mean so less visuals does not necessarily mean less information or less charts, right? Because you can actually display multiple charts or multiple, much more information in one visual, but this is still one visual. So in this case, this is a multi-card visual. This is a ZebraBI cards visual, and it's just, and this is much faster than having 3 separate visuals on a page. All right, we'll discuss this in much more detail, but the performance analyzer is the key part here. And now if we extend any of those options here, we see DAX query 100 milliseconds. That's okay. Visual display 15 milliseconds. That's amazing. That's great. And other, this is for the visual to wait for the other things, and it's like half a second, right? 500 milliseconds. That's okay for a page, right? So if we had half a second for every page, that would be quite nice. All right. Now, if you're using direct query, like in my other example here, now this is a different situation. Now I've changed the page. Okay, let's clear and refresh this. All right, now I have a table here that uses the direct query as the connection mode. So in this time, the data is actually not imported, not loaded into Power BI, but it's actually reaching out to a database server, running the query on the database server, returning the results into Power BI, displaying it, and so on. In this case, you'll find another item here called the direct query, right? And this is now the additional time needed to fetch the data from the data source. And in this case, if it's direct query, this is some sort of a relational database, right? And in this case, this is then added to the total time. So the DAX query, this time actually means the time for fetching the data for the direct query, and then process, and then this number here, the DAX query time is always larger than the direct query, because once the data is fetched from the database, the Power Query needs to process the results, and the DAX, the engine, and so on. So this is adding to this time. So this is then the total time for the data here, and then again the visual display and the other category, waiting time for the visual. All right. So this is the first step here. So in this case, maybe you see the DAX query is already larger than the visual display. So I might want to explore this option here. But still, of course, if it's like, all right, 600. So it's still quite low because my database is already optimized and I have an amazing internet connection here. So, it's fine, but it's not necessarily. Typically, you will see, you might see big times here in the DAX query part, which means that then you need to take care of your data model. All right, so this is the performance analysis. This is your starting point. Now, if you want to analyze your performance to a larger extent, especially when the DAX query part will be very large. What you want to do is click here to copy the query. All right. So now we've copied the query that Power BI actually generated. And where do you paste it to, right? You paste it to another tool called the DAX Studio. All right. So DAX Studio is, a third-party application. It's a great tool for data, for performance analysis. So you copy the query, and now here you will see the actual query that runs, behind the scenes, that was generated by Power BI, and you'll see a lot of things like, how filters are, how the query is generated. How filters are stored and so on. And then, you run this, and now you can do a much better analysis here. You can see the results here. You see the history of all the queries with all the timings. And then here you have the server timings indicating how many milliseconds did the query take, and so on. And this is then the starting point for analyzing the actual query, thinking about, okay, what actually went into this query, and so on, which is more advanced analysis. So we don't have the time today to go into the details, but if you do have a problem on the database side, then this is then the right tool to do it. All right, to finalize the performance analyzer part here, you also have the option to export this the performance information from the analyzer, and you can export it as a JSON file, and then open this file, and you will see that it contains more detailed information than just what you see here. So you will see more exactly what is actually going on for each individual visual, when did the query start, and so on, for each event, when did it start, and then for each individual visual, you will see the queries that were run, and so on. So this is also one thing that you might want to explore. But for the basic analysis, to actually determine whether your problem is in the data or on the visual or report side, this is the first indication. So just to repeat, if your DAX query part here is very big, like a second, 2 seconds, 5 seconds, then you have a problem with the database, which is actually true in most cases, right? So to wrap this up, so use the performance analyzer in Power BI Desktop. This is your starting point. You need to measure your performance to then manage it, right? Because you will find that most of your performance problems actually lie in your data model. You copy your query to the DAX Studio and analyze it there for further analysis. All right. One more thing. If you are using the row level security can also greatly affect actually the performance. So in this case, you can head over to modeling and use the view as command inside Power BI Desktop, right? And here, if you have different roles for your row level security, then you can actually choose the role that you want to analyze, right? And then when you choose the role, you will see that the performance may change, and probably it will change because then the row level security will kick in and the performance will be slower. Okay, in some cases much slower, and then you need to fix your row level security, which is also one thing that we will talk about. All right, okay, once you understand the global picture of your performance, what can you do about it? Now, 80% of performance issues lie in your data model. Okay, so data model, actually the logical data model, the conceptual data model that you're using in Power BI is the number one issue for performance, number one reason for performance issues. All right, so if you've got a model like this, like on this picture, lots and lots of tables with lots and lots of lines, all right, this is a messy data model that is slow for sure. Okay, so as you can see here, everything is all tangled up. There's a ton of joins between tables, a ton of relations, meaning unnecessary joins that the database engine needs to perform, and so on. Then there are bridge tables inside here, and then to bind everything together, for this to actually work, you're using complex DAX formulas, like DAX formulas in multiple lines, and even 10 lines and 20 lines of DAX, and so on. So if you have long DAX formulas, this is an indication that you have a bad data model in most cases, right? In most cases. Then many-to-many relationships, typically because you have multiple fact tables or something like that. You end up with many-to-many relationships, and also unused columns. So there's a lot of stuff inside this model that was just dumped into this data model from the database, but nobody actually thought about the real requirements. Is this being used or not? And if it's not used, throw it out of the model, because in Power BI you can always add data fields and columns later on. You will not break the existing reports and so on. It's very flexible in this regard. So, if you have too much stuff inside, this model will be slow. And then, of course, the reports and dashboards will be slow. All right, in edge cases, but in general, one-to-many relationships. Only necessary elements. So, only columns that you actually need, that your users actually need in their reports. only simple DAX formulas, simple DAX calculations, mostly for things like non-additive measures, calculating some, ratios and stuff like that. Quite easy things where you use a divide function, for example, and that's it. So if you can transform your model into a star schema like this, then your model will be much, much, much faster. Actually, this transformation from this messy model to this picture, this is an actual use case, right? So this model actually represents the exact same functionality than the one on the previous picture. And with this technique, we've been able to reduce the number of tables in the model from 32 down to 8 tables, right? And of course, it's much, much faster. It's like 5 to 10 times faster for typical data queries in the reports that were used in this case. So why do we keep seeing all those messy data models in Power BI out there, right? So there are a couple of reasons. Number one reason is the lack of proper data preparation, lack of ETL. So people basically just load all the tables into Power BI and then start to draw relationships and so on, and then they need to figure out the calculations and KPIs, and they start writing DAX, and this DAX then needs to be very complicated, and so on and so on and so on. So this is the issue, is that there was no data preparation. So you need to combine your tables and merge them together and so on before you even load them into Power BI, right? Next thing, so this is the item number 2. The reason number 2, separated fact tables. So you might have a fact table for the sales, like the actual sales, and then you have a plan that's originated from another table, and you just load them both into Power BI, and then you'll figure out the relationship later, right, in Power BI, and then again you need to start like knitting them together and so on. So you need to combine this before you load things into Power BI. All right. Lookup tables instead of proper hierarchies, dimensions. So the dimensions, as you have seen in the star schema, it's basically one table for one dimension. Okay. So you need again to combine the tables, maybe apply some logic in the ETL process to actually process this so that you have a proper dimension. And then, including just every possible column, because we might need it, somebody might need it sometime, and then you just include everything, and you don't think about, okay, what is really necessary here. And then the 5th reason, typically for messy data model, is also unnecessarily complex row level security. So row level security can be a performance killer, and you need to be really, really cautious how you do that. All right, so this forces you to use complex DAX, which will be automatically slow. A lot of joins will be in your queries that Power BI will generate, and so on. And this is more what I call data knitting than data modeling. All right, so by data modeling, we mean a structure in your data model, analytical data model, that is quite determined, right? So first of all, do your data preparation. Okay, combine, append tables that are similar in structure and are used for the same purpose. So the fact tables, like the sales, actual sales, and actual plan, and different forecasts and stuff like that, just combine them into one table or append them, right? Then make sure to transform your hierarchies and attributes into single table dimensions. In the end, you want to have one table of your customers with all the attributes and all the hierarchies of a customer. Like, a customer belongs, to a certain region, country, and so on, and has certain properties. And then you load everything into one table, combine it, and so on. And then the third step, filter out everything that you will not need. All right. And this is something that should be done in the data preparation stage. So this is typically what should be done in Power Query, not in DAX, right? So you need to use Power Query or do this on your data source, especially, of course, if you're using the direct query connection mode, then you need to do this already, on your data source, like in SQL Server and so on. But just push this, do this before the DAX model, right? So first the DAX preparation, and then you have the DAX model, right? The data model, the final data model that you people will see in Power BI, then should look like this, right? Basically, in the DAX model, you just in certain cases, of course, you add the relationships. You write a bit of DAX, of course, for your KPIs and certain functionality that you need in addition to your data to calculate certain data categories and so on. And this is then the data model in DAX. So you need to separate this and do work before you move to Power BI. And now we have, at least in theory, 4 types of data models in Power BI. So flat table, star schema, a snowflake schema, and a messy model that I've just represented. So a flat table is the most basic model in Power BI. We all started by just loading one simple table from Excel, for example, into Power BI. Or, for example, you have a Hyperion data source or SAP or something, and you just start by exporting a lot of information into a flat CSV file, and then you load this into Power BI, and you're doing this month by month, right? Or just adding the data from those files into Power BI. And now, if this is just one table, we call this a flat table model or a denormalized table. So everything is denormalized, everything is stitched together, everything resides in one table. And the problem of this approach is that you will end up with enormous redundancy. So for example, like here, let me share my pointer here. So you see things like business unit, customer, product group, and so on. This is a value that is just repeated in each row. And of course, now, if this table is very long, if you have 1 million rows, you will have 1 million instances of a business unit in each row. So it's just being repeated, okay? And this, of course, will result in slow reports in the end. So this is completely fine if you have a very limited, not very limited, because Power BI is actually a very strong engine and a fast engine, but sooner or later you will hit the limit where this will become slow, especially. Why? Because these elements like business unit, customer, and so on, these are typically used as filters on Power BI pages. All right. And now the database engine needs to, needs actually a complex query just for the filter. And this adds to the time of your report. So that's why it is important to separate this information about business units, customers, and so on into separate dimensions. So if you do have a flat table model at the moment, consider splitting it apart and into a star schema. Okay, so I will talk about star schema a bit more right next after this. There's also a version of like a next level of star schema, which is called the snowflake schema, which is actually has worse performance than star schema. So do not use the snowflake schema, all right? Because so the difference is that in a star schema, you have the whole dimension, like your customers, your products, in one table. So it's very complex, and there's always just one join. So just one relation between your customer and the sales of that customer, for example. Here in the snowflake schema, you have your customer, and then you have the properties of your customer, like countries and so on, in another table. And you need another join and another join and so on. And this is slightly worse than the star schema. So if you do have a snowflake schema, consider maybe merging together those dimensions, and you will arrive at a star schema. And then if you have a messy model, then you have a big problem. And because this is just something that you need to get rid of, and you need to just, have a project and try to untangle your model. And basically from every other table, you need to move to star schema. So if you have a flat table, you need to normalize it. So like separate the dimensions into a star schema. If you have a snowflake schema, then merge, combine the tables for dimensions, and you'll arrive at the star schema. And if you have a messy situation, then you will need more work, like combine the fact tables, combine the dimensions, and then you will arrive at the star schema. Okay, so the winner is definitely star schema for, I would say, 95% of situations. The star schema is by far the fastest model. And why am I spending so much time on this topic, right? Because if you want to achieve performance gains of 5 times or 10 times, then just little technical performance tricks will not help. Because with those, technical tips, you can increase the performance by 5% or something, but you cannot reach a completely, another level, like, having 10 times faster reports. And now if you have 20 seconds for a page to load, then, you need 10 times better performance to bring it down to 1 second. Okay, so you will need to remodel the things, and the logical data model, the way how your data is organized, is affects the performance by far the most. All right, so what exactly is a star schema? So star schema has first a fact table, which is the table like sales that contains facts. All right, your measures. Okay, your measures. And then this fact table is somehow related to your dimensions, like your sales process, products, business units, customers, and so on. Okay, so it's very simple. And then between the business units and your sales fact table, right, you have a relationship. And this relationship should be one-to-many, okay, in like 99.9% of cases. This should look as close to this as possible. All right, but now a couple of rules. If you want this model to work really fast, run really fast in PowerBI, a couple of things here. So first of all, the measures. Okay, the fact table contains all the measures, so all the numbers. Okay, and those measures can be implicit or explicit. So the implicit measures are basically the columns that you already have from your source data, like, the cost, revenue, and so on. And then you make them, then you add an explicit measure, which is basically, for example, a sum of revenue. All right. So the good practice here is actually to not use directly in your reports, not use directly the columns that you have in your database, but first create the measures, explicit measures, and then just hide those implicit measures that you have in your source data. All right, this will help you with maintenance and so on. Then what else is in the fact table? Then you also have the so-called foreign keys. So, the fields that are used for the relationship. So the business unit ID, on the customer ID. Okay. These fields should be integer fields, numbers. So not text stored as integers, not some strange codes that you have and so on. Try to have them as integer numbers, as short as possible, because you want to keep your fact table very like narrow and long, if this makes sense, right? So you know, all of your columns should be very narrow. So basically, they should have as less characters or less the minimum number of bytes to represent one value, right? So do not use text or floating points or and so on. Just have integer values like numbers 1 to 3 work best, and so on for those foreign keys, right? IDs, and then you hide them. All right. So in the end, your fact table for an end user will just be simply a collection of measures that and KPIs that people can use. All right. And this is it. There should be nothing else in the fact table. That's it. Just the keys for the relationship and the measures. If you want this to work fast, then think about granularity. Of course, if you load every, you know, every document, like every sales order with the number and with the timestamp, like for every 5 seconds and so on, into the fact table, and you want to analyze that, of course, this will be a lot of data, and you know, it'll be slower. Okay, so think about what granularity is actually needed. Is this like daily level or monthly or and so on, right? And then design for this granularity that is really actually needed. Try to reduce it. Okay, then the dimensions. In the dimensions, hide the foreign keys, and then of course everything else will be text. Make sure that you remove any unnecessary columns so you keep everything lean and clean. And then a couple of special tips for the calendar dimension, of the time dimension, or the time date calendar dimension, as it is typically called in PowerBI, is a slightly special dimension. And use the date or the date ID, not the date time, which is basically a timestamp with the, you know, number of milliseconds and seconds and so on. So you just need the date for this. Okay. Avoid calculated columns. All right. Typically, you don't need the calculated columns. Just use measures. And then if you need something special, maybe you can do it in Power Query and actually generate the needed column as a normal column in a dimension. All right. And then short tip, also remove the auto date table in Power BI. There's a setting for that in Power BI. All right. And then relationships, one to many. Okay. Okay. So much about the modeling. So use the star schema, make it clean, and use the data types that are very short as possible. Okay. Next thing, push calculations down the BI stack. So for example, the calendar dimension is many times done in DAX. It's very simple to start. There's a formula. Basically, you can just calculate the whole calendar table with a simple DAX statement. We have done it in our webinars. We have shown how to use it, which is totally fine if you have a small data model and so on. But if you do have performance problems, then you want to generate things like that, calendar dimension and other like calculations and so on, basically down the BI stack. So you do not want all of those formulas to get triggered every time people change something in a report, right? If you do it, for example, in Power Query, what will happen? The calendar will be generated and calculated at the time when data is loaded, but not at the time when the user clicks on a report. Okay, so basically DAX formulas, you can look at them as volatile formulas that always need to calculate something, and all this calculation is running each time the user clicks on a filter, changes a page, and so on, right? So if you push those calculations down the BI stack to Power Query or to your data source, so you can generate your time dimension in your SQL Server. It's much better than to have it in DAX, right? Because it will not consume time to calculate it. It will be calculated on the SQL Server, and then it'll just load it into Power BI. All right. Okay. And then use only simple DAX formulas, typically for non-additive measures and so on in your data model. Okay. The last point here around data models, you also have connection modes in Power BI that are very different. So the fastest one is the import mode, which is when you basically just load the data once into Power BI or import it into Power BI, and then it's physically stored in your Power BI with the X-Velocity Vertipack engine, which is brilliantly fast. It's an in-memory database that compresses columns and so on. It's a columnar store type or tabular, database that works extremely fast in memory. So this is always the fastest mode, okay? So if you can load the data, import the data into Power BI, it will be much faster than, for example, direct query, typically, okay? You've got other benefits like full DAX support, full Power Query, and so fully featured Power BI. All right. However, the problem is data limitations and the refresh limit, because you can only refresh data 8 times a day. So that's why people or bigger companies then start using the direct query method, which can be very slow. So there's red here, not because direct query per se is slow, but because it can be extremely slow, because then you are not really using the fantastic engine of Power BI, but the query is sent to your data source, to your SQL Server typically, or something like that, and then it is run there, and then it returns these results. So which means that the responsibility and of course the performance optimization needs to be done on this data source, which means that you need to have your indexes and so on. So you need then a professional database administrator or somebody like that that will actually make sure that all of those queries run fast. And you need to do this optimization if you're using direct query method. Otherwise, it is very likely that your reports will be slow just because you're using the direct query method. All right, then you have the Live Connect, which is typically better because with Live Connect, you connect to Azure Analysis Services or Azure Synapse, which are enterprise-wide, enterprise type of databases that are also tabular databases, almost the same as the one in Power BI. So it's typically fast, but somebody needs to take care that it actually is fast and that you have star schemas there, okay, so that it actually runs fast. And then there's the composite model, which is typically something that I would recommend if you're using the direct query, because it's basically a combination of direct query with imported data. And this is with composite model, you can actually also compensate for slow performance of the direct query. All right. So import is fastest. Direct query is very tricky, so you need to be cautious. It can be slow. And yeah, this is the takeaway, I would say. Row level security is also problematic, can be a performance killer, especially if you have a very complicated schema for security. So it is very helpful, or I would say it's a must, that you have a star schema model and then apply row level security. Otherwise, you'll have terrible performance problems. So first have a clean star schema model, then add row level security, try to add it to as simple rules, like apply it to dimensions and so on. And then if it's still a problem, consider alternative designs. If you have very simple rules, then maybe, you don't even need row-level security. In Power BI, you can maybe just split the model and, have two separate reports and two separate databases for data sets for different audiences, right? So basically split the audiences, split the data set and report, and maintain one for one group of users and the a different one for a different group of users, and just publish this to separate workspaces, and then you don't need the row-level security, and things will be faster just because you split them into several parts. Okay, so to wrap this part up, do your data prep, implement a clean star schema. So this will give you the most performance gain. Push calculations down the BI stack. Everything that you can calculate before DAX, calculate it before DAX, including your calendar table. Make it in Power Query or on your source data. Choose the right connection type. Import is very fine and works great. And it works for quite a lot of information because Power BI has huge compression, very good compression. So, even try to use import mode before you go to direct query method. And simplify your row-level security. These are the 5, I would say, top most reasons how to speed up your data model. Now let's switch over to reports and visuals. Okay, the number one issue that we always see is just simply too many visuals, as we have seen in the beginning. All right, so let me just head back to Power BI. This report, I'll just try to do a very quick redesign. All right, now this is loading and loading and loading and loading and loading, and it was what, like 5 seconds? That's too much, right? You don't want to have 5 seconds or 10 seconds and so on. So ideally, you want to have it under 1 second, right? And why? Of course, this is now an extreme case where each thing here is a visual. So this is a visual, you see, and then and then because of the limitations in Power BI of Power BI visuals, then you start adding things like even single numbers, and so this is one single number, and I mean, you can tell that this is stupid, but sometimes people are forced to do this just because they don't have enough features in the visuals, especially the native visuals, right? And of course, this will lead to slow reports. So I will just delete everything here. So, okay, before I do that, let's just refresh this one more time. All right, so it was like, what, 5 seconds, still loading. So it's more than 5 seconds, right? Okay, let's remember this. Now I'll just delete everything. Sorry. Let me delete this. All right. Okay, now I'll just refresh it just to see. Okay, without those, we are down to 700 milliseconds. All right, this is below 1 second. Okay, but now I don't have all of my beautiful KPIs and so on. Okay, so now what I want is to, instead of all of those elements, all of those visuals, actually try to convey this information in one single visual. And what do you need for that? You need a multi-card visual. Okay, so I'll use the Zebra BI cards custom visual for that. All right. By the way, as you see here, there's a new version coming for those who are using Zebra BI visuals. Some great new features. But the point here is, all right, now I'll add some information. All right, so I have the actual versus previous year, and I think we had a plan. So there were actually three values here. Or was it the forecast? I think it was the forecast. All right, but now this is only one, right? And we had 3 KPIs, I think, or four KPIs. So now you take your KPIs and you bring your KPIs into the group data field. Okay, and now you have the same information that you had before. So for KPIs with all the growth rates and so on, and even additionally with a chart. Okay, but because now everything is in one visual that displays multiple cards, okay, everything is much faster. It's still under 1 second. It's 800 and something milliseconds, which is, quite okay. And even now, if you make this more complex, so now adding like a month here. Okay, now we'll, all right, now I didn't get anything because there's a filter for the month, filtering my visual here. So let me try to click here, quickly click. All right, and just filter this out so that we get the month here. All right, so now even with, monthly chart, let's have it like this, for example. All right, even with all these information, it is still fast. Actually, now it renders a bit faster, but it's still very, very fast. So because it is much more important that you put things into one visual. So this is what I call consolidate your visuals, right? So have less visuals, but of course, don't throw the information out because people want to see information. So you need visuals that can present multiple things in one visual. These are things like multi-card visual, small multiples, cross tables, and so on. Now in this case, for example, now that I actually have the chart here, this is the revenue chart. Maybe I can just redesign this. I don't need this chart anymore. This is gross profit here, and it's my revenue. So it's basically the same information here. I can actually delete this, right? And basically, I have the same report, or I think even a better report, in just two visuals that runs fast. All right. And I can even turn this one into Zebra. Now you don't need the calculated variance anymore because the Zebra BI visual is doing that. And yeah, let's refresh this. Sorry, like that. It's still very, very fast. So from 5 seconds down to 600 milliseconds and so on. And now it does not matter. You can add more data now, like, okay, this is actually, sorry, this is plan. And this is previous year. All right. So now I have more measures, but it's still one visual. So the time will be more or less still the same, you see. So, but I have reduced the number of visuals, which is the most important thing on the front end. All right, one more thing. So do the same thing with your tables. So for example, instead of having multiple tables, right, you can have just one table. This is just one visual, but it's basically a cross table, okay? Because it has rows and it has a hierarchy in rows, but then it also has, parts or segments in the columns, all right? So for example, the Zebra BI visual, custom visual does that. Matrix visual, the native matrix visual also has this capacity. So you see, this would be a normal table, just measures here, but then you can create a cross table to display more information. So you just add your things like, I don't know, the period calculation or something like that. You put it, into columns, you group by this, and this visual is still fast. And now the result is a very fast report because it just has one visual, just one single visual on the whole page. This is the fastest possible way to do it. And you just need to combine things, right, with cross tables. And then the last method would be the small multiples, right? So here again, is this fast or not? It's actually extremely fast. And I have 9 charts. And it's, it took 33 seconds because it's import mode. And the visual display is 16 milliseconds. It's crazy fast, right? And it's very, that's why it's, and it does not really matter how many elements. Of course, if you add now a lot of elements, it will become slower. So now this is, again, the ZebraBI charts visual with charts for every product group. It's actually 144 product groups. So let's refresh this, see it's less than half a second, right? And it's basically because of the slicers. You see, the slicers took more data and more time than the visual to get the data for everything for 12 months and all the products and render it and so on, because it's one visual. Okay, so this is extremely important. Reduce the number of visuals. All right. This brings me basically to the end. One more thing here. Also things like comments, right? So the ZebraBI visuals have this capacity to add comments, right? So without it, it's a normal chart, but you can actually take your comment and just add your comments to the comments field. Now, this visual is practically as fast as chart without comments. It's still one visual because the comments are inside the same visual. So this is the advantage of having visuals that can display multiple things, like not just one simple chart, but chart with comparison to plan and an additional chart. So it's actually two charts. So this is the relative variance inside the same visual. Okay, it's much faster. So that's why it just renders extremely fast. All right, let me try to bring this to the end. Okay, so consolidate your visuals. Make sure that you start with a landing page that will run fast. So when you structure your reports and dashboards, have a landing page that will load extremely fast, like I have shown, right? Like in half a second maximum. So keep it to very good visuals without a lot of elements and so on, but to the point with variances and so on, right? And this needs to be extremely fast. People will open it, it will load, they will see, and then they will click. Then they will click on certain elements. And then if they want more, they will drill through to another report page, right? Because when they will do the click, they want to get more information. So they're motivated to open another page. And this is a completely different thing, because once a user clicks on something and he expects that he will see something that he wants to see, he's prepared then to wait more, for a longer period, like a couple of seconds and so on. But if you open the first page and you haven't even seen anything yet, right? Here you want fast results. So it's even more important that your landing page, the first page of your report, just loads blazingly fast. All right. So that's why I refer to our signature dashboard layout design pattern that we call overview detailed. We have covered this to quite an extent in our previous webinars. Okay. And make sure that you check this out. Last news from ZebraBI, we have a new ZebraBI tables visual that works blazingly fast. It's suitable for deep hierarchies, and it's a separate visual now on the app source. So it's really great news from ZebraBI. Let me just, if I can just show you really quickly, because sometimes in custom visuals, it was not possible to use certain data methods. And we have worked with Microsoft on this, and Microsoft has delivered a brilliant way how to solve the performance issues with deep hierarchies. So now you see the new ZebraBI tables visual actually just needs a couple of milliseconds for the query and to display the visual, because it loads the data on demand each time the user clicks and so on, right? Whereas before, the visual had to load all the data in bulk And this was a performance killer for very deep data hierarchies. Here, as you can see here, I have data like that's just spans. It's a very deep hierarchy. Now even this is solved for custom visuals as well. So ZebraBI is now the fastest tables matrix visual out there with this technology. So this is completely new. It's out now. All right. So with that, I would invite everybody to import the ZebraBI visuals from Microsoft App Stores if you like the visuals. The basic version is free. I hope that, I opened some minds here and there. So from data modeling to consolidating visuals on your pages. So just think about it, and hopefully some of the tips today will help you deliver much faster reports and dashboards in Power BI. All right, guys. The resources, the webinar recordings are here. So make sure to check this link, zebrabi.com/webinars. Go to our homepage and check out the webinars on the topics that previous topics that I presented. And do we have any questions now? Mark, over to you. Oh, for some reason, I can't hear you.
Oh, sorry. Yeah. Can we hear?
Up.
Yeah. So yeah, there was a lot of discussion in the comments section, so it was
right.
really great. Also, there was a suggestion that we should have a separate webinar just to cover the Q&A on the performance. This would be a great idea also, but yeah.
It's a huge topic. It's, All right, so let's take some questions.
Yeah, let's just dive in. So some of the most pressing ones. So let's start with one of the latest ones. So why is the consolidated visual so much faster compared to separate visuals?
Yeah, because so what happens if you have several visuals, Power BI needs to handle a lot of things. First of all, each data query, so each visual needs to be loaded, needs to be rendered inside the visual, right? And it triggers its own separate data query. Okay, so now if you have a situation where you have like this, sorry, the one that I just called the slow report. So now each and every visual triggers the DAX query. So Power BI needs to handle now a ton of queries, and it actually handles this in parallel. Okay, but it cannot handle like I don't know 30 queries in parallel. So that's why you get this other time that will just add to this, and then it's and then this data needs to be sent back through the Power Query engine and the DAX engine, and then it is passed into the visual on the front end, being serialized and stuff like that. So it's a lot of like overhead for each visual, and this overhead just gets added and added. Whereas if you have one visual, there's much less overhead, right? So the data, the visual needs to fetch more data, right? Typically, because fetch data instead of for one chart, you need to fetch the data for 10 charts. But this is small potatoes for Power BI. It's not something, if you have 10 charts, each one has 12 months or something, it's 120 data categories. That's nothing, right? So the change in the time to get more data is very, very slow, but there is no overhead anymore, and that's why it's much, much faster. That this is really the number one reason, believe me, reduce the number of visuals.
Yeah, indeed.
Even images, unnecessary images, like backgrounds and stuff like that, just reduce everything, delete them.
All the, let's say, layout elements can be packed even in a JSON theme background, or
Yep.
or you can just grab a screenshot and just use that as your one image, and it will be better than having
Yes.
each line, each element
Yeah.
visualized
Look at
separate.
that. Look at that image loading, 200 and visual display. All right, the visual display was 800. 80 milliseconds. Well, that's not a lot in this case, but when you add things up,
stacking them up,
yeah, you're in seconds quite fast. All right.
So there was an excellent question regarding tabular editor. So is it recommended to use tabular editor with the best practice script to analyze your report measures, and any reason
Yes,
not
great
to?
question. Actually, I think, Mark, you're kind of a specialist for that. So yeah, definitely I recommend that. Mark, give us a deep
If you
dive on
want
that.
to, if you want to really go deep into your performance optimization, tabular editor and the best practice analyzer available through the editor is a great way to do it. You can also run automatic scripts that would check your entire data model. But yeah, it's really good to check this out. We will also send out some recommendations or checklists for the performance after the webinar, where links like this will be included. So there are other experts like Phil Semark, Michael Kowalski from the Microsoft team, also Daniel Otek here, who is
The author of the
of
application.
tabular editor. But yeah, that's a great way to go. Like the next steps. Okay, going deeper into each particular element.
We'll add some links on the recording page. So if you're watching this live now, you'll get the recording link. But later on, for people who are watching this on YouTube, there will be a link in description with further links what to read.
Yeah. So okay, then there was a question regarding when you're talking about leaving out things that you don't need. So when you say filter out any columns that will not be used, should we just try to hide the columns in the BI desktop, or should we try to remove the columns from the source data?
Not necessarily from the source. I mean, if you're sure that nobody will ever use it, then remove it from your source data, right? So, I mean, today I was focusing on the Power BI part, not the whole BI stack, right? So I would not, at the beginning, delete it from your model in Power BI. Just delete it. And then you will see if somebody will complain or will get back to you with this requirement. Oh, but now I would like to do the analysis by the data field X, right? You say, all right, no problem, and then you add it back. So it's better to keep it in your source data. For example, I mean, typically, at least in larger companies, you have some sort of a data warehouse where there's a lot of data there, right? But in Power BI, start lean. It's like it's agile approach to BI that works much better than the old school waterfall projects where everything was prepared in advance, big models, big documentation, and then you went out to users, and then 2 years later you were like exploring who is using what and why and so on, and throwing out things. No. This never worked actually in the history of BI. Okay, start small, start with what people really need, and then add things. Because luckily, Power BI is an extremely flexible BI tool, much more than any BI tool before, like especially decades ago. So you can go for this approach, and it works really well.
Excellent. Okay, so there was actually a twofold question regarding query folding. So is there any way to differentiate among M scripts for query folding and no query folding? So I can help you with that.
Yeah, that's
so
a hard question.
Yeah, when you go in Power Query, in the applied steps, you have actually the ability to right-click on the step and see View Native Query. If that is available, that means that steps or the steps up to that will actually, and you will actually see the query that is getting folded right there. If that is available, query folding is taking place. If not, and you will break it with a particular step. So if you add a step there, that will break that. That button will not be available, and also you'll get an let's say alert message that you will actually be now doing something that will break the direct query, and that you'd have to switch to import. Right? Yeah. Right. Here you can see that.
So this one, Mark, right? So native query.
Yeah.
Just to show it here. All right. That's great tip, Mark. I did not know that. Thank you. Perfect.
Okay, so there's another question on query folding. So the second part, any easy way to identify which applied? Yeah. Actually, you'd probably have to that there must be a list of which steps would break this native query. But yeah, you can just check if a transformation, or you can just try it, and if it breaks, it will alert you to this. So yeah.
All right.
Okay, so the next question, is there a difference between prepping data in Power BI, Power Query, or using an external program, then uploading clean data to Power BI afterwards?
Is there a difference? Well, the difference is, of course, I mean, the difference is then in the load, in the load time when you are loading data into Power BI. So it depends now on basically on your refresh strategy. Right. So, I mean, Power Query was designed exactly for that, for you to append, merge the tables, clean out data, filter out data, and so on, add some columns and things like that. So it's a really great tool, and you can do a lot of transformations with Power Query. But this now depends. I would say it depends on a lot of things. I mean, it depends on the connection mode for once, right? So if you're using the direct query, then typically people will skip Power Query, because in direct mode, Power Query is also very limited, because it was expected that, if you are doing direct query, then you already have like a relational database and something, and you do your ETL there on the relational database. And this, it can be a very nice situation for you if you already have a data source that is clean. It's a clean data warehouse. Then you can just, use the direct query to access it, or still use the import mode. And basically, you will have one-on-one relation to your relational, data mart or whatever you have there, and you can completely skip Power Query. But typically it's not so. I mean, in this regard, I would say the major advantage of Power Query is you can combine different sources, right? So I mean, the power here is that you can connect to, I don't know, 300 and something different data sources, and you can combine everything together before loading into Power BI. That's for sure a huge advantage of Power Query, which is there for you to use. Mark, do you want to add anything?
No, I think this sums it up. Okay, as I see there, we have a lot more questions to answer. Maybe we can try to answer as much as possible and then take them offline. But yeah, to transform Snowflake into Star, can we use Power Query to append tables? But this is also affecting updating times, right?
Yes, sometimes this certain transformations will definitely increase the times for how did you call it, Mark? How did he call it?
Update times, but
update times, yeah, exactly.
So yes. when you're appending the queries, it's you can also enable specify on the particular table to not load it twice, right? So you'll be doing the load time only once, right? You don't have to, yeah.
And there are lots of strategies then how to how to make sure that your refresh times will not explode, because once you start doing that, but that's in general, this should be the principle. You start at the top of your BI stack, so in DAX, and you start pushing your calculations and everything down the stack. So then next step is Power Query, and then down your data source, and then you will have a fast DAX model, but then maybe your refresh times will increase, okay? Which is, of course, it's a problem, but it's at least you have solved the problem for the end users, right? And now, of course, you need to start on optimizing your refresh times. And this is query folding that we were mentioning before, and other strategies that you have available in Power Query are then the next step. We did not cover this today, but of course, in the end, you also want to have fast refresh times, but not necessarily every time. If you have a monthly reports or even daily reports, and you just refresh them like once a day or a couple of times a day, you have enough time. It can run for a monthly report, it can run the whole night, for example, or it can run 1 hour or half an hour or a couple of minutes. It's not an issue, right?
Yes. Okay, so maybe two more quick questions. So after enabling many features in data models for users by using switch statements and disconnected tables, so in disconnected tables scenarios, is there any performance decrease using those disconnected tables? Should we try to limit how many tables are used and so on?
Yeah. That's a great question. So in our webinars, we have shown a lot of tricks, with disconnected tables and switch statement, which is one of the options, how to actually consolidate things like putting KPIs into one dimension, which will increase the speed of your things, because this is the precondition that you can actually take your KPIs and put them into the multi-card visual and have everything in one visual to make sure that everything runs fast. But then you need to do this, and then you have the cost of the switch statement. However, the cost of the switch statement is like 20 times smaller than having separate, 10 separate visuals, right? So it's much better to do that, even though there is a small cost. Now, the cost of the switch statement is small, right? It's small, but also you have other ways to achieve the exact same thing. So you have the calculated groups, right? So the calculated groups is, from the functional logical perspective, exactly the same thing as the combination of switch statement with a disconnected table. So these are the two methods how typically you can do your period calculations, your KPI consolidation and things like that. So you can use the calculation groups as well. Of course, if you have the premium and so on, because it's not available for the Power BI Pro.
Yes, but also with introducing the switch statements, of course, you can introduce within the switch statements some, let's say, not optimal calculations.
Yeah, of course, if you have a complex DAX there, if you have just a simple switch statement like, the case of KPI, if it's 1, then take sales. If it's 2, then take this. Then this is simply just basically selecting one column from another table.
Yeah.
And it's almost no performance. You will definitely not have issues because of that.
If you have issues with the switch statements, it might be because you need to optimize those statements, and there are detailed articles on that, on how to do this.
And that's a different thing. Well, people are abusing this for like in a typical, like in P&L statements and so on, like the traditional way of doing P&Ls with the native matrix visual and then the switch statement to calculate everything for each row. That's a completely different thing. That can be very slow, right?
Yeah.
But
okay. Okay. So, and we'll finish with a short and sweet one. So When using files as data source, TXT or CSV, have any difference in terms of performance?
Well, typically files you will just import into Power BI. So typically if you have a CSV file or something, this means that you're doing some sort of export from a certain data source into this file and then load it or import it into Power BI. And this will be fast. This will be blazingly fast because this means that you are actually using the import mode. So all the data from your CSV file is loaded into Power BI, into a Power BI model, and then it runs inside Power BI in memory. So it will be very, very fast.
Yes.
The problem will be if you will have to, if those files will get too big or something, then, but the model will run fast. You'll have fast reports, but maybe you'll have an issue with the refresh times, like how much time does it take to process all those files or something like that. But otherwise, it will be very fast for the end users, I would guess.
Yes, and in general, you want to leverage the power of VertiPack. So that's
Absolutely.
the main reason why we are using the import mode. And if you really need live data and so on, it's better to use live connection. As analysis services, live connection is also using the VertiPack engine.
Exactly.
And you're leveraging the same power from that.
That's why what we see from the practice is that, almost in all the projects where we were, kind of involved, the connection mode that was used, and there was a huge performance issue. There was almost always direct query. Almost always. So try to avoid direct query if you can, but if you have it, make sure that your databases are optimized, and just you'll have you need some experts for also to optimize the data source.
Yeah, direct query in general should be used just for professionals who really know what they're doing. They have optimized the source for the direct query, but you also need to consider: do you need live data? Do you need it now or always? If not, then you should not go to
many times people just
assume that
they just it's not really an issue, because many times it's completely enough that you refresh your data like 8 times a day, which is the limitation of the import method, right? And they think that they need to have direct query because they are enterprise and it needs to be live and so on, and they have this. But even if you have a data warehouse, you don't need to now use direct query because you have this relational database. You can still have it and import the data. So you will create a copy of the data for sure, but this redundancy, the copy of the data will be in the best analytical and the fastest analytical database in the world, which is the VertiPack engine of Power BI. And with direct query, you're not using this engine of Power BI, the VertiPack, but you're using the SQL Server or something. So you need to then do your optimization there. And you'll need a SQL, professional for the SQL Server or whatever your source is.
And still at best, you'll get, let's say, 5 times slower performance than import or live.
In any case, it will be slower, even if you optimize it for sure. Yeah. But of course, it has other advantages. I mean, it's not like otherwise it wouldn't be here. So it's much more scalable and so on. I mean, it's in the end, import method does have limitations in terms of data size.
Okay, I think, Andrei, we answered a lot of questions.
We need to wrap it up.
Yeah, thank you for the presentation. And the rest of the questions we'll handle offline in the follow-ups as well.
Just keep the questions going. We'll get in touch. You have the links here, how to find it. So search for us on LinkedIn, follow us on YouTube, and get in contact if you have more questions. And then see you at the next webinar. Cheers.
Cheers.